Hello everybody, today we are going to be taking a look at lesson 4, which is going to be talking about percent yield. Now, this usually takes place after we've completed a lab. So when we calculate our gravimetric Stoich calculations, and let's say we're expected to make a certain mass of precipitate, we are then going to go into the lab and see if we can get close to that mass. And then we do a calculation called percent yield to see how close we were to actually getting it to the goal. So the learning goals for today are to determine the success of a lab through percent yield. Identify sources of error that correlate to the percent yield. Let's get started by first doing some review of a gravimetric Stoich problem. The review says 2.28 grams of sodium metal is placed in excess solution of magnesium nitrate. Determine the mass of sodium nitrate produced. The first thing that you're going to do is write a balanced reaction. So, 2 sodiums react with magnesium nitrate. Remember to include your states, your coefficients. It's going to produce 2 sodium nitrates and magnesium metal, which will be solid. Okay, from here you're going to list what you know and what you don't know, what you're looking for. I know that there is 2.82 grams of sodium metal, and I am trying to determine the mass of sodium nitrate. So I'm looking for grams of sodium nitrate. Okay, let's begin writing our Stoich statement. So we are looking for mass of sodium nitrate. You're going to begin with what you know. So I go 2.82 grams of sodium. We now need to convert this into moles. And the way that we do that is we use our molar mass. So I like to list things that I'm using underneath my reaction. I'll kind of leave some extra space there. The molar mass of sodium is 22.99. I'm going to divide by that. So that grams can cancel out. Now that I have grams, I have mass of my known. Okay, so I'm just going to review this. Okay, so from here to here, I have mass of Na, which is my known. From here to here, I have moles of sodium, which is also my known moles. Once I have reached this step, I can now convert it into my unknown. And the way that I do that is by using my molar ratio. So this is going to be 2 moles of sodium. And what we're looking for is sodium nitrate. So it's going to be 2 moles of sodium nitrate. Let's see what cancels out here. Moles cancels out with moles. Sodium cancels out with sodium. Ooh, too far. So from here to here, I now have moles of sodium nitrate, which is my unknown. The goal is to find the mass of our unknown. The last thing that we need to do is use molar mass to convert our moles into mass. Molar mass of sodium nitrate is 84.99 grams per mole. Sorry, my molar mass is actually 85. Okay, we are then going to multiply by 85 grams and divide by moles. See what's canceling out here? Moles cancels out with moles, and I am left with grams of sodium nitrate. So lastly, from here to the end, we have mass of sodium nitrate, which is my unknown. So understand how you can stop the sentence wherever you need it. So if we were to be finding moles of our unknown, we would stop it here. If we were looking for moles of our unknown, we would stop the sentence here. If we're looking for mass, then we would stop it here. So now, once I plug this into my calculator, my final answer is going to be 10.4 grams of sodium nitrate. Okay, let's now get into percent yield. Percent yield, this is the ratio of the actual product obtained compared to the calculated product. From Stoich calculations. The formula for percent yield is equal to experimental yield over calculated yield multiplied by 100 because it's going to be a percent. That is a horrible 100. Okay, let's break this down. Experimental, these are your lab results. So this is what you actually end up weighing at the end of the lab. Your experimental yield, this is your calculated expected result. So this is calculated from Stoich. Okay, so if your lab was to go perfectly, in theory, this is the number that you should get. All right. Experimental yields are the results from the lab. Calculated yield is obtained from stoichiometry calculations. So I'm just going to write Stoich. Example 1. In a chemical analysis, 2.5 grams of sodium reacts with magnesium nitrate. What is the predicted mass of the precipitate? Okay, so this is pretty much the same reaction that we have from our review problem, but we're looking for something else. So same thing, we're going to start off with a balanced reaction. 2 sodiums, metals react with 1 magnesium nitrate to produce 2 sodium nitrates plus magnesium metal. So the precipitate in this case is going to be our magnesium metal because it's not soluble in water. The second step is to list what you know and what you don't know. So we have 2.5 grams of sodium, 2.5 grams of sodium metal, and we are looking for the mass of the precipitate. So we're looking for grams of our magnesium. Great. Now, we're going to go ahead and do the Stoich. So this is nothing new so far. This is what we've already been doing. So So mass of my magnesium is equal to you're going to start with what you know. So 2.55 grams of sodium reacts. So we now need to find our moles. And if we have mass, you're going to use molar mass, which is 22.99 grams per mole. Grams cancels out with grams. We can now use our molar ratio. You're going to divide by 2 moles of sodium. And then multiply by 1 mole of magnesium. Remember, that's the 1 in front of the magnesium. It's invisible. 1s are invisible in chemistry. Moles cancels out with moles. Sodium cancels out with sodium. Okay, from there, I am now going to turn our moles into mass. And the way that we do that is we need to use molar mass. The molar mass is going to be 24.31 grams per mole. We are going to multiply 24.31 grams per mole. Moles cancels out with moles, and I am left with grams of magnesium. You get an answer of 1.32 grams of magnesium. Okay, now this is our predicted mass. Since we use Stoich for this, this here is my calculated mass. Part B says Group A obtained 1.60 grams of precipitate. PPT means precipitate. Find percent yield. Okay, so the formula is percent yield is equal to experimental yield over calculated yield times by 100. Okay, so let's go ahead and calculate this out. My experimental yield is obviously the yield that we found in the lab. So group A obtained 1.6 grams in the lab. So that's their experimental yield. So I'm going to go 1.60 grams. Now my calculated yield is what we had up here. Okay, 1.32. This is what was calculated. This is what was expected. Okay, so 1.32 grams. And then you multiply by 100. Okay, and if we round this to the nearest percent, or 3 significant digits, I get 121%. Now, a lot of kids will be like, oh, that's fantastic. We made more than we were supposed to. However, I'll show you at the end what matters more. Okay, so we're going to be looking at another group and comparing the two answers after. So group B obtained 1.7 grams of the precipitate. Find their percent yield. So again, the formula for percent yield, I spelled yield wrong. It's okay. Experimental yield over calculated yield times by 100. Now the experimental yield for group B is 107, and the experimental is the same. Okay, it's still 132 times by 100. That is going to give me 81.1%. Okay, and the last part asks me, which group has better results? So I'm just going to set up a little bit of the information here. We had group A have a percent yield of 121%, and group A, oh sorry, not group A again, group B had a percent yield of 81%. I'm just going to round it to the whole number just for the sake of comparing. Okay, so the goal is to get to 100%. Okay, the goal is to be the closest group to 100%. Okay, so here's 121. That is 21 units away. That's 21% away from 100. The other one is 81, which is 19% away. So if I look at the two groups, I would have to say that group B has better lab results because it was closer to 100%. So group B has better results because closer to 100%. Right. So if they were to get 100% in the lab, they would be getting about 1.32 grams in the lab. That means they would be getting the same amount that is expected. So the goal is always to be near 100%. Okay, what are some possible sources of errors that could happen during a gravimetric analysis? So if the goal is to get to 100%, here are some possible sources of error that could happen in the lab. These are errors that cannot be controlled by humans. So let's say if your percent was over, okay, so over 100%. Some possible sources of error could be precipitate not fully dry. Okay, it may look dry, but there might be still some little bits of water. Even though once we vacuum it or we let it sit over the weekend, it may not be fully dry. Another thing is impurities. Okay, so impurities could be the glassware, or you don't know if the concentration of the solutions are 100%. Something accidentally got into the solution and you can't see it, and that could have added to the mass as well. Let's look at for some source of errors that could be lead to a percent under the percent yield, under 100. Some possible sources of error could be, again, impurities, and also reaction did not go to completion. Okay, so let's say we've stirred the two solutions together. They've been sitting there. We've been stirring them for 5-10 minutes. We don't see any more precipitate forming. So again, to the eye, we think that the reaction is done. But behind the scenes, maybe the reaction had only gone 90% or 95%. So we can't really tell that with a human eye. I'm going to leave it at those two for now. I'm going to let you guys brainstorm and come up with your own, and we can then discuss them after. Okay, now that we've gotten the gist, let's do one more example, and then I'm going to have you guys try one on your own. In a chemical in a chemical analysis, 3 grams of silver nitrate in a solution is reacted with excess sodium chromate to produce 2.81 grams of filtered dried precipitate. Using stoichiometry, predict the mass of the precipitate expected in the reaction. So here we are actually looking for our calculated yield. Now ask yourself, am I using the 3.0 grams of silver nitrate to find my calculated yield, or am I using the 2.81? Well, you're going to ask yourself, which one was used in the lab? Okay, so I'm saying that 2.81 grams was used in the lab. Okay, so this here is my experimental yield. So we can't use that number. Now, a lot of students will just go directly to the 3 and say that that's their calculated. You need to actually calculate your percent yield. You can't take it from the thing. So to help us, we're going to start off with a balanced reaction. We have silver nitrate reacting with sodium chromate okay, to produce silver chromate, which is going to be a solid because it is not aqueous in water, and you're using page 6 in your data book to determine this. And lastly, we have sodium nitrate produced. I'm just going to write the 2 there because, yeah, and this is aqueous. Last thing you're going to do is make sure everything is balanced. Should be a 2 there. Yep. Okay, everything looks balanced. From here, you list what you know. So this is going to be used in our Stoich. The 3 grams of silver nitrate, I'm going to list that under silver nitrate. We are looking for our precipitate, grams of our precipitate. Hey, this is going to be my calculated yield. This number here, not this number. This number is used for the Stoich. Okay, a lot of students get confused and will use that number when calculating the percent yield. Okay, let's perform our Stoich. So we are looking for mass of sodium chromate. We're going to start with what we know. Silver. Okay, so start off with 3 grams of silver nitrate. We then need to convert this into moles using molar mass. So I'm going to go 169.87 grams per mole. I'm going to divide by this number, 169.87 grams per mole. See what's canceling out? Grams, grams. Now I have moles of silver nitrate. Once we have moles, we can then use molar ratio. Molar ratio, I have 2 moles of silver nitrate multiplied by 1 mole of silver chromate. Moles cancels out, silver nitrate and silver nitrate cancel out. So I now have moles of silver chromate. The last thing you need to do is multiply this by molar mass so that you can get your grams. Your molar mass of silver chromate is 331.6 0.73 grams per mole. Okay, so I multiply that. Moles cancels out, and I'm left with grams of silver chromate. Perfect, that's what we are looking for. And I get, once I calculate that in, 2.93 grams of silver chromate. Great, we found our calculated yield. Part B is find the percent yield. So, percent yield is equal to experimental yield divided by calculated yield multiplied by 100. Going back to our problem, remember, this number here was found in the lab, therefore it is our experimental yield. This number here was calculated, so it is our calculated yield. So we're going 2.81 grams divided by 2.93 grams. Notice how they're both measured in grams, allowing those units to cancel out. Multiply by 100, and our percent yield is equal to 95.9%. If I'm ever asked to round this to the nearest percent, that means it's the whole number. It would be 96%. A lot of times you may be asked that when doing problems, round to the nearest percent. In this case, it would be 96%, which is the whole number. You're going to try this one on your own. Solution made up by dissolving 9.8 grams of barium chloride to be completely reacted with a second solution containing dissolved sodium sulfate. Predict the mass of the expected precipitate. And then if 10 grams of precipitate was actually formed, calculate the percent yield. So I'm going to fill this in. When you are ready, you guys can unpause and check your answer. Okay, let's go through this. So first step is always to write a balanced reaction. And from there, you're going to see what precipitate was formed using page 6 in your data booklet. The barium sulfide is our precipitate, so we will be looking for mass of barium sulfate. You're going to then use Stoich to calculate this mass out. Once you use Stoich, you're going to get a mass of 11 grams. You are then going to use that answer in part B to find your percent yield. In the lab, the group found 10 grams of the precipitate actually formed. So this becomes my experimental yield. We're going to use the percent yield formula, and we are going to calculate it out. So my experimental we have established is 10 grams, and my calculated is 11 grams, which we calculated by using Stoich. Once I plug that into the calculator, I will get a final percent of 90.9%. I'm rounding to 3 significant digits because nothing was asked of me. If I were asked to round to the nearest percent, my answer would be 91%. Okay, but in this case, I was not given any rules, so I'm going to use the regular rounding rules.